All right. Welcome to a new week. Today, I think we're going to kind of go out of sync with the textbook a little bit. We're going to move to chapter 12. And the main thing that I want to talk to you about today is the I. The way I'm going to choose to do this, because at school it would look different, we'd probably do a dissection or I'd share some student, like school based links to do some dissections that are virtual. Is I'm going to use this website for now. It's not perfect, but instead of spending lots of time looking for something, I'm going to go with this. So, what I'm going to do is talk about some structures in the I. And then when I'm done, what you can do is you can go back and forth and write down what these different structures do that I've talked about and kind of use it as a bit of a learning tool. And then I'll share the link to it as well, and you can go on and play with it. Today, we're just going to talk about normal vision and features of the eye. And then in the days to come, we'll look at how you correct for problems with your vision. And so, what it means to be colorblind, and I'll share a test you can do for that, and also glasses and how they correct your vision and things like that. But for now, we're just going to do straightforward normal vision. So, I'm sharing with you this page, which right now doesn't look like much. This right here is supposed to be the eyeball. Let me just take that off for a second. Okay, this is supposed to be the eyeball right here. And so this would be what we would call like a cross section. So eyeballs are actually like little round spheres. It is possible, I always mention this, that your eyeball, it's sitting in a socket, which means it's sitting between these bones you can feel right here. But it is possible there's an injury where something can like get lodged between your eye and that bone and be popped out, which is pretty disgusting. It would stay attached to your head by something at the back of your eyeball. We're going to look at here called the optic nerve, and there's some other muscles and things that are still attaching it, but you can still see when it's out there. Mind you, you feel pretty out of sorts because the world is not really lined up the way it's supposed to be. But yeah, when it is out, you can see it's a full round little sphere. If we did a dissection, you'd see it's a little round ball. So a cross section means that it's been sliced in half, and then you're looking at it from the side. So this would be like the front of your eyeball here, and then this would be the back of your eyeball right here. And the idea is there are objects out here in front of you in the world. They're not, for the most part, some of them would be if it was a light bulb, but for the most part, they're not giving off their own light. You can see them because when the light shines on them, the light reflects off the surface of the object and then bounces towards your eye. So that's why you're seeing them. Okay. We are going to treat it then as if the light rays have come from some other source. They've hit the object, and then these light rays travel towards, they're reflecting away from the object into your eye, and then traveling actually to the back of your eye, and then they hit the retina, and then that sends information to your brain that produces what you see. So, where we're moving after we talk about how the eyeball works is talking about lenses, not just the one in your eye, but in other places. So far we have an object out here. These are supposed to be light rays that are bouncing off the object into the front of your eye, and then you'll see there's some crossing over that happens here, and then they hit the retina. So what I'm going to do is I'm going to switch this to showing you all the anatomy. You don't need to know all these names, and I'm not necessarily going to call them by all the names here. It's just a link I had that works for other things in the future. And so I'm just going to choose to stick with this one. But don't worry about learning all these names that go around here, and don't worry about memorizing all of their functions. I'm just going to point out what's important. So if I go to this for a second, I guess we'll start at the front of the eye right here. So you can see something called the cornea, and you might actually have heard of the cornea before. It's the very, very front of your eye. You might know about it because sometimes people scratch their cornea. They might get like a little piece of sawdust in there or something else. It's possible to scratch that, and then it'll heal up again. Okay, but that is where light initially comes into your eye. and it's curved, and so it will cause light to bend a little bit, and then head back further into the eye. So cornea is the very, very front, and then the pupil is in here. So the pupil is actually an empty space. There are some um, muscles here and some muscles here. And so you can change the size of the opening, which you might be aware of. So the job of the pupil is to sort of regulate the amount of light coming into the eye. So for example, if it's really, really bright out, your pupil is going to be a smaller circle so that you don't have as much light flooding your eye and you don't get overwhelmed. And like when you see a bright flash, you can't see anything for a while. It's just too much light. So your pupil adjusts to that by shrinking and controlling the amount of light coming into your eye. When you're in a dark space, the opposite is going to happen. The pupil is going to dilate. It's going to get bigger. So constrict is when it gets smaller. Dilate is when it gets bigger to let in more light. So if I'm in a dark room, I walk in, initially I might not see anything. And then the pupil is going to open up wider so more light can get in your eye and then increase the chances that you can see some things in your environment. So this is controlled by your nervous system. It should be an automatic response. Your pupil of your eye is adjusting all the time to regulate the amount of light coming in to allow you to see. The only time that it wouldn't work properly is if there's some kind of interference with your nervous system. So for example, if you're impaired, one of the things they can do is check to see the size of your pupils, because odds are they're not regulating properly. And so most of the time they just open really, really wide, even though there's no reason for them to be open that wide. And so sometimes people can tell by looking in your eyes and seeing the reaction of your pupils whether or not you're impaired or intoxicated by some kind of drug, for example. Another time that your pupils might not be regulating properly would be if you've had a concussion. So sometimes if you've had one of those hits to the head, they'll look in your eyes. They might shine the flashlight in your eye to see if your pupil is changing. And if it's not, that's a sign that there's been some sort of disturbance and your nervous system's not responding appropriately. Okay, so that's the function of the pupil. So the light comes through the cornea, through the pupil, and then behind that, you'll see the lens. So that's the next important structure. The lens can move a little bit. You'll see there's some connections here as well. So the lens can be like extended and squashed back down again. Words are escaping me right now, but you can make it longer and thinner, or you can make it shorter and thicker. Your eye will change the lens based on trying to focus on something. So if there's something close up, your lens has to be a different shape than if something is far away. And once again, your nervous system regulates this. It's all automatic. How much you stretch the lens to change your focus or squash the lens to change your focus. We'll look on that in the next few days. If you have a lens that can't stretch far enough or squish far enough to allow you to focus on the things in your world, then we get into glasses and what glasses can do in nearsighted and farsighted. So we'll come back to that later. Okay. This graphic isn't so great because right here, it doesn't even look like the light is hitting the lens down here. I'm just noticing that now. But pretend the light ray came here. The idea is it would hit the lens. That lens is going to bend the light and then send it kind of focusing in towards this point where all the light rays are going to come together. So the one from here came straight, went right out the other side because it went right through the middle of the lens. We'll talk about how we make these rays later. This one that came into the top, it should have hit the lens here and been bent to start turning back into this focus point. This one down here should have hit the lens. I just went a little too far south there. When it hit there, it should have been re-angled once again to come towards this focus point. And then all those lines cross back here. The lens is redirecting the light to come to a focal point here, farther back in the eye. Okay. Most of what is back in here is like a liquid jelly kind of stuff. So it's a bit of an empty space full of this, like I said, really jelly, transparent looking stuff that fills that part of the eye and keeps it as a round circle. All right. As the light rays travel through your eye, eventually they cross and then they hit back here, this part being the retina. And the retina is where you have all the structures that help you detect color, red, green, and blue, so you can see the full spectrum of colors. One thing that maybe you wouldn't pick up on, and if we were in class, I would show you like a pinhole camera or something like that, which kind of mimics a little space where light comes through as you're looking at the outside world, is what hits the back of your eye is actually upside down from what was out in the world. So because the light rays cross at some point here towards the back of the eye, is that if this was the top of the object you were looking at, the top is now down here. Here's the bottom of the thing you're looking at, and now the bottom's up here. So if this was a tree with like, here's the top, here's the bottom, the tree would be upside down. Here's the top, here's the bottom. So everything on the back of your eye is upside down. That information travels through this nerve here called the optic nerve to your brain, and your brain inverts the image so that everything looks right side up to you. So the world doesn't look upside down. Okay. So those are the basic structures that I really wanted to introduce. Let me do this. The cornea, okay, the pupil, the lens, the retina, the optic nerve so far. Okay. Let me just make sure I'm not forgetting anything. So those ones are really important to begin with. Sometimes some of you can see here, there's all kinds of blood vessels back in here. Some of you may have had the experience of having a little blood vessel rupture in your eye. It usually looks like the white part of your eye has a little bit of blood in it. That usually heals up and goes away. Sometimes people have what's called a detached retina. It's unlikely it's happened with any of you, but tends to be something that happens as you get older. It happened to Mr. Wheatley, actually. He's really prone to it. I don't know if you've had Mr. Wheatley, but he had an experience this year where his retina detached and he was out for a while getting that looked after. But that can be a thing that happens, and obviously it damages your vision. The colorful part of your eye is your iris here. So you would have like the pupil is the hole, and then that colored piece around it would be the iris. I don't need you to memorize that because we're just really talking more about the mechanics of vision than some of these other bits and pieces. Another thing I'm going to highlight, change this here for a sec, is right here where the optic nerve connects to the retina. This is where you have a blind spot. So actually, this little piece here is dark. It's not filled. So the retina would pick up all the light back here, create the image, but because it has to connect to this nerve, there's this one spot right here that where the back of your eye can't actually see or pick up an image. You don't have a blind spot in your vision because your brain fills that in. So it knows you're looking around and it can fill in the piece that you're not actually seeing at any given point in time. So there is that area there. So let me just check one thing before I stop this to make sure I haven't forgotten any bits and pieces that I would normally highlight. I think that'll be good for now. I think I'm going to come back and talk about, like I said, in another lesson about when bits and pieces aren't doing what they're supposed to. I automatically mention some just in conversation. Okay. No, I think I'm good for now. I think I'm just going to leave it at that. So if you wanted to read about the eye in your textbook, it is chapter 12, page 470. We'll show you some of what I was talking about. And then I'm just going to keep adding to this. So for today, I'm not going to give you too much to do. You already had a quiz to check on last week's material. You're going to make your own note on this video about, so just call it structure of the eye. and then put down all of these ones that I've circled, okay, and write down what they do, what their role is in vision, okay? And then I'm going to share this link with you, and I'm going to use it this week to talk about some of the other things that you can see on here, like what if you're nearsighted? What if you're farsighted? What does it mean to be nearsighted, farsighted? What about bifocals and all that kind of stuff? So one thing I'll actually show you while we're here is that this movement of the lens piece. So if I move the object near, is it doing it? Focus. Oh, there we go. It's not doing it very well. So this one, this focus slider, is supposed to show you what's happening with the lens. And so if I move the object farther away, the lens is short. I don't know if you can see that. You have to look pretty closely, but it's getting longer and thinner. And then as I bring the object closer, the lens gets like shorter and wider. It's not a great image, but we're going to talk about that a little bit more. What if you can't adjust as much as you need to? What if your lens can't adjust as much as it needs to allow you to focus on the image? Okay. All right, that'll have to do for now. I'm going to stop the video and I don't know. My thoughts aren't going as well together today as they have other days. So let's leave it at that. And I think I'll make a note, all right, about what you're supposed to do with this. All right, everybody. I will talk to you later, Gators. I didn't turn it off. So later, Gators.